Today we're learning about the derivatives of the inverse trig functions. So let's start with y equals inverse sine, and we're going to find the derivative of inverse sine. And the way we do this is we rewrite this equation without the inverse. So if inverse sine of x is equal to y, that means that the sine of y must be equal to x. Now if we take the derivative of both sides, we have to use implicit differentiation. We get cosine of y dy dx is equal to 1, which means that dy dx is equal to 1 over the cosine of y. Now we don't want this in terms of y, we'd like this to be in terms of x. So let's think about what's happening with that angle. So we know that the sine of the angle y is equal to x. So this has to be the angle y, and sine we know is opposite over hypotenuse. So in order to get that ratio to be x, we can name the opposite side x and the hypotenuse 1. And then using the Pythagorean theorem, this third side would be the square root of 1 minus x squared. Now back to our expression over here, we've got cosine of y. Well, the cosine of y would be adjacent over hypotenuse, so we'd just be left with radical 1 minus x squared. So dy dx is 1 over radical 1 minus x squared. So this means that the derivative of inverse sine is 1 over radical 1 minus x squared. So what this also means is that if we wanted to find the derivative of the inverse sine of u, where u is some function of x, we would still have 1 over radical 1 minus, but now it'll be u squared times du dx. Now we can find the derivatives of the other 5 trig functions similarly, but for the sake of time, I'm going to give them all to you right here. So the derivative of inverse cos is very much like the derivative of inverse sine, but just negated. The derivative of, it's going to change my color here, let's see. There we go. Of inverse tan of some function of x is going to be 1 over 1 plus u squared du dx. The derivative of inverse cosecant is negative 1 over and this u should be an absolute value here. Now we've got the derivative of secant. So notice that the derivative of inverse cosecant and inverse secant are very much alike. It's just that one is negative and the other is positive, just like we saw with inverse sine and inverse cos. And you'll see the same thing with inverse cotangent. Not cosine, but cotangent. The inverse of cotangent of some function of u would be negative 1 over 1 plus u squared, then times du dx.